Hello friends, welcome back. In this tutorial we will study about TCP/IP protocol suite. The TCP/IP protocol suite was developed before OSI model. The original TCP/IP protocol suite had only 4 layers: host to network layer, internet layer, transport layer and application layer. Right? The original TCP/IP protocol suite had only 4 layers: host to network layer, internet layer, transport layer and application layer. Now what happens if we compare TCP/IP protocol suite with OSI model, then we can say that this host to network layer of TCP/IP protocol is equivalent to the combination of physical and data link layers of OSI model, right? The internet layer of TCP/IP protocol suite, it is equivalent to network layer of OSI model, and application layer of TCP/IP protocol suite is roughly doing the job of the session layer, presentation layer and application layer of OSI model, with transport layer in TCP/IP taking care of part of the duties of session layer, right? Now what happens here, we will assume that TCP/IP is made up of 5 layers, right? Actually in most of the books you will find that it is assumed that TCP/IP is made up of 5 layers, right? So what are these 5 layers? These 5 layers are physical layer, data link layer, network layer, transport layer and application layer, right? So what happens here, we have assumed that TCP/IP is made up of 5 layers: physical layer, data link layer, network layer, transport layer and application layer, right? Now what happens with the 3 topmost layers in the OSI model, right? 3 topmost layers in the OSI model, they are represented in TCP/IP by a single layer which is called application layer, right? The 3 topmost layers of OSI model are represented in TCP/IP by this single layer, that is application layer, right? Now see, layers of TCP/IP protocol suite contains relatively independent protocols that can be mixed and matched depending on the needs of the system. So we will study about these protocols, right? But in this tutorial I will give you only the brief outline of these protocols, right? About them in detail we will study in separate tutorials. So first we will study about physical and data link layers. So what happens at physical and data link layers, TCP/IP does not define any specific protocol, right? It supports all standard and proprietary protocols, right? So what happens at the physical and data link layers, TCP/IP does not define any specific protocol. It supports all standard and proprietary protocols, right? Now we will study about network layer, right? So what happens at network layer, right? TCP/IP supports internetworking protocol. In short, it is called IP, right? So IP is the transmission mechanism used by the TCP/IP protocols, right? So what happens, this IP, right, internetworking protocol, it uses 4 supporting protocols: ARP, RARP, ICMP and IGMP, right? So first we will study about internetworking protocol, that is IP, right? So what happens, internetworking protocol, which is in short called IP, right? It is the transmission mechanism used by the TCP/IP protocols, right? It is unreliable and connectionless protocol, or we can say it is a best effort delivery service, right? And this internetworking protocol transports data in packets called datagrams, right? So what happens, this IP transports data in packets which are called datagrams, and each of the datagram is transported separately, right? And these datagrams can travel along different routes. They can arrive out of sequence, right? And they can be duplicated. But this IP, this internetworking protocol, it does not keep track of routes of these datagrams, right? And this internetworking protocol, it does not provide any facility for reordering these datagrams when they arrive at the destination, right? Now as I told, this IP, it uses 4 supporting protocols: ARP, RARP, ICMP and IGMP. So now we will study about these protocols. So first we will study about ARP. right? Its full form is Address Resolution Protocol. This protocol is used to find physical address of the node when its internet address is known, right? So what are these physical address and internet address? About them we will study in next tutorial, right? Now another protocol is RARP. Its full form is Reverse Address Resolution Protocol, right? It allows a host to discover its internet address when it knows only its physical address, right? Now another is ICMP. So the full form of ICMP is Internet Control Message Protocol. This protocol is used by hosts and gateways to send notifications of datagrams problem back to the sender, right? So ICMP, its full form is Internet Control Message Protocol, right? And it is used by hosts and gateways to send notifications of datagram problems back to the sender, right? Now another is IGMP, Internet Group Message Protocol, right? So what happens? This protocol provides the facility for transmitting a message to a group of recipients simultaneously, right? Sometimes what happens, a same message has to be sent to many recipients, right? So what happens, this protocol IGMP, it provides a facility by which a message can be transmitted simultaneously to a group of recipients, right? Now we will study about transport layer. Traditionally in TCP/IP, the transport layer was represented by two protocols, TCP and UDP, right? We studied about internetworking protocol, right? That is IP, right? IP is a host to host protocol, right? And it can deliver packet from one physical device to another. IP is not responsible for delivery of message from one process to another, right? But our final objective is to provide communication between the processes, right? Just transferring the packet from one physical device to another is not enough, right? The packet should be delivered to the intended process from the sender process, right? So what happened? TCP and UDP, they are responsible for delivery of message from one process to another process, right? And this SCTP, it is a new transport layer protocol which is devised to meet the needs of some newer applications, right? So first we will study about TCP, right? Full form of TCP is Transmission Control Protocol, and it provides full transport layer services to application. The TCP is a reliable stream transport protocol. Here stream means connection oriented. It means a connection must be established between both ends of transmission before the transmission starts, right? It means before the transmission starts, a connection must be established between both ends, right? So this TCP is a reliable stream transport protocol, right? And what happens at the sender? At the sender, this TCP divides a stream of data into smaller units called segments, and each segment includes a sequence number, right? And these segments are carried across the internet inside of IP datagrams, right? Now we will study about UDP. The full form of UDP is User Datagram Protocol, right? It is a process to process protocol, and it adds only port address, checksum error control, and length information to the data from the upper layer, right? So as I told you that in this tutorial I will give you only the brief outlines of the protocols, right? About these protocols we will study in detail in separate tutorials, right? Now the next is SCTP, right? Its full form is Stream Control Transmission Protocol, and this SCTP provides supports for newer applications such as voice over internet, right? Now we will study about next layer, that is application layer. This application layer in TCP/IP protocol suite, it is equivalent to the combined session, presentation and application layers in the OSI model. Many protocols are defined at this application layer. About them we will study later in separate tutorials.